So, welcome to my talk about F# and our experiences we made when adding F# to our toolbox. So, a little bit about me and my team and my company. We're a very small company, 16 people, and we are a team of 4 developers. We build an attendance time tracking tool, and nowadays, some will call us a DevOps team because we build the thing, we run it, we maintain it, we get the bug reports, we have to fix it. So we do all of this with 4 developers, and the other 12 employees of my company surround us and help us with users and customers and stuff. So, but because we are only 4 developers, something is really, really important for us to have as simple code as possible, because simplicity means code is easy to read and understand, and with that comes that it's easy to refactor and to adapt. And I'm a C# developer for 20 years now, so I started with C#1, and when I come to C# from C++, I felt, oh, that's much simpler. And in the last 2 years, I had the same feeling about F#. Could F# help us to make our C# code even simpler? And of course, the talk today is only here because I think the answer is yes. So in 2020, I talked my team into doing an experiment and to rewrite a part of our system from C# to F#. It was our calendar module. And the idea was rewrite it in F# and then let's compare the code. It does exactly the same. One is written in C#, one is written in F#. And after I did that, it took me about a month to do it. It wasn't fully complete, but it was good enough to compare the 2 code bases, and the whole team agreed, yes, we should go with F# from now on. And in 2021, we decided that all the new modules are written in F#. We just write C# when we add features, small features to the existing code that we already have in C#. So, and the rest of the talk is the why. But I don't want to bash C# because I have been programming in C# for 20 years and it was mostly fun. And there are some topics where C# really shines. And I want to go through them very quickly. First, C# tooling and the IDE support is just awesome. I don't know any other language that has such a good tooling. Compile speed is really fast. So C# compiler is really fast. I would say the F# compiler is just fast. So it's not slow, but if you compare them directly, C# compiler speed is surely much speedier. But the F# compiler does a lot more for you, as you will see later on. Then debugging in F# is not as good as in C#, but if you do a lot of debugging, maybe you should start doing TDD, test-driven development. When you do some low-level programming, yes, go with C#. If you have really high performance needs, so you do a lot of async things with tasks and await, and you have really, really high performance needs, you should go with C#, because the C# compiler optimizes these task state machines. But I would say in a normal business applications, as the one that we build, the F# code is fast enough. When you do some WinForms or WPF programming, yes, go with C#. If you really like OO heavy libraries, like for example Entity Framework, you can use them from F#, but let's be honest, it's a pain. Or when you really, really like inheritance, probably C# is a better choice. You can do almost everything in F#, but yeah, it's not built around inheritance. So let's come back to F#. As I already said in the introduction, one big difference between C# and F# is that in F# everything is an expression. There are no statements. Whereas in C#, most code is written with statements. So let's look at the statement here. A very simple example. And statements have some problems. This code has the problem that first I need an initial value for the result, and it's actually never used, so it's just clutter. But I have to assign something, otherwise the code won't compile. Then we have this result equals 42. The problem here is I can't extract that from this statement here. I can't extract the assignment. I can extract the 42 because that's an expression, but I can't extract this the whole statement, and that hinders composability a lot. And finally, the 17 here, what happens if I forget to assign the 17? I probably have a bug because I return 0. We can rewrite that in C# into an expression with the ternary operator, and it's much smaller, but being small is not the most important thing. It's much more important that I don't have an initial value. The clutter is away. I can extract the whole thing in one branch. I can extract the 42 because it's an expression. And if I forget the 17, it won't compile, so it won't happen. Looking at the same code in F#, it looks like this. It's quite the same. So if-then are not statements, it's an if-then expression. And as you can see, I don't have to annotate the type of B because the compiler knows B must be a Boolean because it's used in the if condition. So, and you may wonder, what if I don't have any values? So in C# with statements, you just don't pass anything. If you have expressions, you always have to pass something to a function, and the function always returns a value. So in F# there is this unit value that symbolizes nothing. So this is the compute tick function takes nothing and returns nothing. And as you have seen in the talk by Chris, you can discard a return value, and you can do that with ignore. So the compiler in F# won't compile if you discard values without using the ignore expression here. So the benefit is that if you can't simply ignore return values, it helps reducing bugs. In our case, when we switched to async await, so there was a time where we didn't have async await, and when we introduced it, we had a lot of bugs because we didn't await the tasks. And if you are not in an async method, the compiler won't complain. And we had quite some defects because we didn't handle these return values. The other thing is that if everything is an expression, refactoring becomes simpler because I can just change the return type of a function, and the compiler will check that everything is still okay. Then we heard it for Chris, there are records in C#9 now, but I don't like them. We use them in our code, but actually I don't like them. And the reason for this is that you can define them in different ways. So these are two ways to define immutable records in C#9. One looks like a constructor, the other like using properties. And the problem is, when you want a value, you have to know in which way you defined the record so that you get the correct value. And I find that just confusing, unnecessarily confusing, I must say. In F#, you define a record like this. There are two ways how you can write them, but it's still the same thing. It's just, do you want to write it on a single line or not? If you write it on a single line, you have to add a semicolon between the fields. But there is only one way how to get a value. As you can see, for the small a, I don't have to say that it's a big A. If the compiler finds a record that with matching fields, it just takes that type. Okay, the next thing is equality. We heard from Chris that records support equality. That is true, more or less. Let's look at this example here. We have a data record with a name and an array of values, and we have a compute method. We get twice the same value, so A and B contain the same values, and we compare them. Unfortunately, this returns in false because the array is compared by reference and not by sequence equality out of the box. You can change that, you can overwrite the equals of this data record, but out of the box, it's not the same. Same code in F#. You have a data record, you have the compute function, and A will be equal to B. So as long as you stay in the F# type system, you have full deep equality. That's really nice and helps to reduce defects because equality checks can be very hidden in your code. For example, if you like to use LINQ, in LINQ you have contains, group by, union, distincts, then you have dictionary lookups, you have contains key on a dictionary, for example. All these things use equality behind the scenes. So if you use a record with arrays in it, they probably will fail. And I think that's a big, big trap with records in C# because you get used to, oh, they implement equality, then you add a reference field, a field with a reference type, and it will fail. I don't like such surprises. Then we have this or that types. So something is something or something else, but not a third option. For example, we have a temperature. So a temperature is either Celsius or it's Fahrenheit. So I decided to use double for Celsius and int for Fahrenheit just to have two different types. So both records implement an interface. Yeah, that's probably the way I would go in C# nowadays. In F#, I would go a different route. I would use a so-called discriminated union that says the temperature is either Celsius or it's Fahrenheit. Now, I can use pattern matching. I can use the switch expression that Chris has already shown us in the last slot. And I can say, well, I'm a person that really likes warm weather. So for me, warm means it's above 25 degrees Celsius or above 77 degrees Fahrenheit. Otherwise, it's not warm. The same in F#. I use pattern matching as well. In F#, it's called match. It's just the same code. It's equally good or bad. So just the same code. But if you do something like this, give me the measure of the temperature. So it's say, if you have Celsius, return Celsius. If you have Fahrenheit, return Fahrenheit. And then I have to add, otherwise, yeah, I don't know. Maybe let's throw an exception or return empty string. I don't know. But I have to handle this third case in C# because when I use interfaces, it's an open type hierarchy. So I can add additional temperatures. So that can be a benefit or it can be a disadvantage. In F#, because the compiler knows temperature is either Celsius or Fahrenheit, there is no third option, I don't have to add this third case. And when in the future I will add a third option, the compiler would warn me that this match expression here is not complete. So it won't compile when I say treat warnings errors. On the C# side, yeah, the compiler will be happy because there is this otherwise case. So I have to use some Shift F12, find all usages to find all the switch pattern matching switches to correct my code. So there are a lot of potential bugs. But maybe you say, yeah, but using switch expressions on types isn't OO, and you are absolutely right. In an OO style, this should be modeled that iTemperature, the interface, provides a method getMeasure. And then every implementation should implement this method. That's correct. That would be better OO design. But let's face the fact, nowadays, most developers, most C# developers, and I count me in on that, like using switch expressions because it's easier than real OO. Doing real good OO design is extremely hard. And one disadvantage is that OO means I hide state. And so every method that wants to operate on this state has to go on an interface. And this interfaces grow and grow and grow when the functionality in my system grows and grows. So I think OO nowadays doesn't really scale with a lot of features. So maybe that is a reason why a lot of C# developers like to go with switch expressions, and then you have the problem that you have to find all these switches when you add new cases. It's just unneeded complexity, in my opinion. And if you really like the pattern matching stuff that Chris talked about, you can do even more in F#. There are so-called active patterns where you can define a so-called pattern when it's warm, when it's cold. So what are the conditions that it's warm or it's cold? It's the upper path. And on the lower part, you can see how I can use this is warm or is cold in pattern matching. And this can help to reduce complexity in business logic a lot. There is a saying amongst the F# folks that make illegal states unrepresentable. That means I use these discriminated unions that I can model my domain in a way that it's impossible to have an illegal state. And if illegal state is impossible, I don't have to handle it. So if I can't have a null, I don't have to handle null. If I don't have a third option for a temperature, I don't have to handle this third option. And that makes it much harder for defects to sneak in. The next thing is I like to read text left to right, top to bottom, like I read text in a book, for example. And again, let's look at a small code sample here. I have a customer with a name. I have a method getCustomer, and I just cheat here. For every ID you give me, I just return Charles. I have a method to get the name of the customer. So it's just a very simple example here. And then I want to combine that together. So give me the name of a customer with an ID. One way to write that in C# is to nest the method call. So give me the name of the customer with the ID, but that's hard to read. So what I do mostly in C# is I introduce some local variable customer. So let's first get the customer and then get the name of the customer. But the word customer appears here a lot. And I think it introduces a lot of clutter here. So it's not as short as I would like the code to be. Let's look at F#. I have a customer record. I have a function to load the customer and a function to get the name of the customer. It's just the same as on the C# side. And in F#, I have the so-called pipe operator. You probably know that from the command line. It's just put the result of the first as the argument of the second. So let's start with the ID, give that ID to the load customer function, give then the loaded customer to the getNameOfCustomer function. So it combines much easier than the C# code. I can add pipe and pipe and pipe as many as I want. It doesn't get visually much bigger. And if I use this combination of these two functions many, many times, I can even build a new function that consists of the combination of these two functions with the help of the function composition operator. But in our code, we use that maybe 2 times, so it's not that important. Pipes are very important. So with these pipes and this composition operator, it makes code really easily to be combined in F#. And the code just stays easier to read and easier to understand because there is less noise than in the C# code. So before I come to the bigger example, we need to cover some basics. Basics like asynchronous computing. So in C#, you probably know there's the async keyword, you have a task. So you say, I return asynchronously, and the value I return is an integer. So, of course, here the compiler would complain because there isn't a wait in this async method, but it's just for the example here. If I call this method, I should await it, and I probably should add the configure await false to prevent deadlocks if I'm not sure in which context this code will be executed. And important is that the await looks like I extract the R is extracted from the return value. The asynchronous method returns a task of int, and only the int is assigned to R. So I can continue and do some compute on this R value. You probably say that's obvious, but we'll see why I said it the way I did. In F#, I have an asynchronous function, and I use the async keyword to say, hey, this is async. And this is called a computation expression. So there isn't only the async computation expressions, there are a lot of them, and you can even write your own. And that means that the signature of this function is it takes an int, and it returns an async of int. It's like on the C# side, it takes an int and returns a task of int. Here, it returns an async of int. Async of int. So if I want to call that, I again use the async computation expression, and instead of awaiting, I use let bang. Let bang R is equal to asynchronous ID. That means it's the same, you can think of it as the await. The let bang means that R is of type int, and it's the value of the async result. So I can use it to compute something additionally, like adding 17. Actually, behind the scenes, it's not like the await, but for you, if you come from C#, think of it, let bang is like an await. So it's so-called computation expression magic happening here. And if you're in F# and you really want to work with task and not async workflows, you can use the task computation expression from the library ply, for example. So just replace the async keyword with the task keyword, and these expressions will return tasks. Again, the compiler can't optimize these tasks as the C# compiler does, so they run a little bit slower. And the async computations have the benefit that they are called. When in C# you start a task, it starts immediately. When you have in F# an async workflow, you say it when it should start. And that helps with composability. Then you have things like optional values. We have seen in the talk before there are nullable reference type, or here I have a nullable value type. It says it either has a value or it hasn't. A simple example here, if the ID is even, return the value, otherwise return null. I could do the same in F#, and in F# I would use the option type. So instead of having null, I would have none. So the option says either it's some value or it's none. It's a discriminated union, as we have seen before. And the nice thing is it's much easier to work with options than it is with nulls. We have seen all these null coalescing operators and null handling, and it's just simpler to work with options because you can, for example, use the option computation expression. You say call optional with the ID, and if we have a value, then let's continue. So this return r plus 17 is only executed if we have a value. If optional ID returns none, the option computation expression will stop and just return the none directly. It's kind of an early return. And sometimes we have a result. That means we execute an operation and it can succeed and it returns something, or it ends in an error. Again, a very simplistic example here. If ID is even, we return the ID and we have no error, so we return null for the string. Or we fail because it's an odd number and we don't have a real value. So that looks very complicated, and that's the reason why we never do that in C#, but it's really easy in F#. So it's a get result function. If ID is even, then return OK with the value, otherwise return error. So the result is always either OK or error. And again, I can use a computation expression to continue calculating stuff as long as we are on the OK path. When we enter into an error, we will early return. I also can call the method and match on the return value. So okay, if it's OK, then it's value. If it's an error, then you have the string error here in this example. All this computation expression I've shown you are from the library FS Toolkit error handling. So now we are ready for the big example about happy path coding. A small exercise for us is we have a customer with an optional name and the data with an amount. And as input, we get customer ID and a data ID. The first step is to load the customer by its ID. And maybe we find the customer, maybe it isn't there. Then we load the data. Again, it can be there or not. Then we get the name of the customer, if it has any. We get the amount of the data. That is always there when there is a data. And at the end, we want to return a tuple containing the name and the amount. If anything goes wrong, we want to know that something went wrong. So on the left side, again, the C# code, on the right side, the F# code. So first, we define some records. And I think that's probably the only slide where the C# code is smaller than the F# code. But again, that's not the main thing here. Okay, then we load the customer. Again, it's example code. We only find the customer if it's ID 42, then we return Charles. Otherwise, we return default. That means null. That means we didn't find the customer because it's a task of nullable customer. I do the same in F# as I want to load the customer. And here I use the async result computation expression. That means this expression returns something that is both async and it's a result. It's the combination. And here I say, is the customer ID 42? If not, if that is false, then you have an error. We didn't find the customer. Otherwise, we can continue. So this do bang here means execute it. If you end in an error, we stop. Otherwise, we continue. So if it's 42, we can go to the return expression and return Charles, our customer. And if we have 42, we would directly end with the customer not found error. To show you this, if I call it, I can match on the result. And here it's a little bit tricky because below there is only an async computation expression. That means it's async. So the let bang will unwrap the result so that customer result can be used in the match to see if it's okay or error. Please don't get confused by that. Then we load the data, and here for the example I just return the data. It's always there. Then I have a method or function to get the name of the customer, and it's an optional value, so I just return that. Again here, if I want to do some additional computing, I could use the option computation expression to get the name, and if there is a name, I can continue. You see, it's always the same pattern here. So now let's put all these things together in the get customer name and amount method. First C#, I load the customer, and if it returns null, I return null. So as you can see, the task is a task of a nullable tuple with name and amount. So null means it ended in an error. Then I load the data, again, I check for null. Otherwise, I continue, I get the name. If it's null, it's an error again. And if we get to the bottom of this method, then I know everything went well. I can return the name and the data amount as a tuple. So now the same in F#. I still have an async result, so it's something asynchronous that can be okay or not okay. I load the customer, and because I use the let bang, the customer will only be assigned if that is successful. If it's an error, the whole function will immediately return. Yeah. So it's like a kind of an early return that's happening here in the error case. Then I load the data. I compute the name. So say, get the name of the customer, and if it's none, we have the error customer has no name. If it has a value, I get the value into the variable, actually it's a value name, and then I can return the data. So, and that's the most important slide in this presentation, because with this comparison of this code, I could convince my team that we should go with F#, because in our code base, we have a lot of code that looks exactly like this. Load some data, if it's successful, continue. And it just reads much, much easier on the right. Actually, we didn't write the code in C# as the code on the left, because it's just too noisy. You can't read that anymore. So what happens, you go with exceptions. You say, oh, I just tried to load the customer, and if you can't find it, you just throw an exception. But that's the easy way out. It makes the code easier, but you never know, did it really work? Do we really work with exceptions on the inside? So it's much, much harder to get the code correct. And using exceptions for cases that aren't exceptional actually is bad design. But it's the thing we did to keep our code readable in C#. But again, in F#, there's a really nice solution. It's really clean, it's concise, it reads well. It also writes well. And at the end, to make the example complete, is when you call this method or function, we can react on the result. Either it's a customer and an amount, or we ended up in an error. And as you can see, F# has now also string interpolation. And if you want, you can have typed string interpolation, something C# can't have. Just as a side note. So to sum this segment up, computation expressions help us a lot to hide plumbing stuff. Things like handling async, errors, and stuff alike. We can focus on the business logic. And I already said that, but you can write your own computation expressions if you have to. In our code, we just use the things that are there in F# core libraries and in some additional libraries that I've shown on the slides. Yeah, it just simplifies reading, understanding, and writing code a lot. And I would say that's my main feature of F# that helps to write easy to maintain business applications. So we started with F# in May last year, and in the next segment I want to summarize the experience we had with F#. Something that is important for me is a common coding style, a coding convention in my team, because when everybody writes the code more or less in the same way, it just gets easier to read code from other people. So a common code style helps, excuse me, makes reading code faster. And in C# we either use tools like stylecop or the resharper to show us violations. But normally there is a lot of manual work involved. So a lot of hitting Alt-Enter to fix these things, or just say, hey, writer, please fix all this stuff for me. But it doesn't feel that great, actually, for me. In F# we have also tools called Fantomas. It's just fully automatic, and it layouts your code so that it matches all the coding styles you want. So it's not as mighty as the stylecop thing, but it's much easier to use. Then something that is discussed a lot with people talking about F# or coming to F# is that in F# all the things have to be put in order. So in C#, when you write classes and you have files and namespaces, you can order them as you want. Normally they're just shown alphabetically in the Solution Explorer, but there is no order you have to follow. And one disadvantage of this is it's really, really easy to introduce cycles in C# code. So namespaces or classes that reference each other in a cycle. And the bad thing about that is that cycles makes it really hard to refactor code, because if you have a cycle, there is no beginning, there is no end. So where should I start? Everything has to change at once. And therefore, in bigger systems, we always used some additional tooling to show us these cycles so we could split them. In F# you have strict ordering, so the files are strictly ordered, the content in a file is strictly ordered, can only use the things that are defined above. So there's an implicit strict order, or the order is explicit actually. That means you can't have cycles in your code, so you don't need additional tooling. You can't have this negative effect. There is one exception if you have, for example, a recursive like a tree, a recursive structure like a tree. You can define cycles in one file if the types are closely together. But normally, you just have no cycles. And that makes also code easier to understand, because if I read a function, I know all the things that this function can use are above. So at least I know the direction where I have to go and look for some stuff that I need to understand this function. Then you have type inference. That means I don't have to write something there. The compiler just can know it by parsing the rest of the code. And that means it's just less code I have to write, it's less code I have to read. And there is quite some type inference in C#, like when you use the var keyword. In C#9, you have this new variant where you don't have to write the type if the compiler can infer it. Then in LINQ, there's a lot of type inference. And for example, also with the default keyword, it returns the default value for your type. So if it's a reference type, it's null. If it's, for example, an int, you get 0. So, but the type is inferred. And if you like these things, you definitely should give F# a try, because F# extends that to values function and generics. So it infers generics for you. You don't have to write all this very, very long list of tuple of something. So the compiler infers that for you most of the times. That also makes refactoring much easier, because I can just change a type and the compiler will just propagate it through all the system and see if it still can compile. But there is a but to it. Sometimes type inference in F# makes code really tricky to write, because if the compiler infers something wrong, you get really strange error messages. So from time to time, I have to annotate some types to help the compiler to show me a better error message. To sum up our experience of our last 12 months, so I'm no F# expert. I'm developing F# for 12 months, but the things we found out is that it's much easier for us to model our domain with the F# type system than the C# type system, mainly because there are discriminated unions. So there is no third option. So we don't have to handle this third temperature as in the C# case. And we found that it's much easier to focus on the intent of our code and not so much on the wiring with this computation expression. Like I called it the happy path coding. Just code the happy path. The rest is handled behind the scenes. So to come to an end, it's these 3 points that, let me say, I prefer F# to C# is our business logic code is much easier to understand because of this computation expression, this happy path coding, the union types. Code is simpler to refactor because of type inference, the strict ordering, and again, the union types. And defects have a harder time to hide in our code because everything is an expression, there are no statements, and the really good type system of F#. So I'm at the end. If you liked what I said, maybe you can go to my blog, Planet Geek. I blog about our journey from switching from C# to F#. So there's a lot of interop stuff in there because 90% of our code base is still C#. So, and I write roughly half C#, half F# at the moment. So I'll blog about the problems we find and our solutions. And if you want like to play with the code samples in these presentations, there you can find them in a GitHub repository. So that's it for now about F#. You're both muted.
We are indeed. It's a difficult thing. We keep doing that. But anyway, really great talk. I truly enjoyed seeing both languages in comparison. I think the chat has been on fire. I think some have seen their preference for their own language confirmed, which is good, I guess. For me, I truly enjoyed seeing both and expanding my .NET language worldview, so to speak. To your experience, if I would want to start with F#, do you have any tips on where to start learning, where I should go and dive into this?
I have a blog post about that on my blog, how to start learning. There are some great books. There are some great courses. Yeah, there's stuff there to start. And I probably would look for a mentor that you can show some code and the mentor can reflect on that code and give you some tips, because at the beginning it's hard to let C# style a little bit go. So you have to find a different way to design your code. So we can design like in C# in F#, it works, the code will run, but it probably gets a bit easier, simpler when you start to add more of the F# way. But at the beginning, that's hard, and I'm still learning. So, but yeah.
Yeah. To that effect, I mean, yes, we can go to your blog, of course. So if I were to dive in, should I expect that everything that I'm used to will just work? Like, imagine I'm using CSV helper, for example, in C# to import CSVs in my application. Will I be able to use those libraries as well? Or is your experience that that's a bit harder? Or
the interop from F# to from F# to C# is really great. The other way, it's not as good, but you can use most C# libraries. So actually, the most libraries we use are C# libraries. There are some exceptions, like, for example, Entity Framework, because Entity Framework uses a lot of inheritance, and then you can do it, but it doesn't feel great. So, but F# understands C# very, very well. Yeah, I think the team tries to make sure that F# understands all the things C# knows. There are some exceptions like default interface implementations, I think, but normally you can just use the C# library. We often introduce some wrapper functions to make the usage a little bit F# friendlier, so that you can use pipes, but they are normally really, really simple.
And things like records, does that all work out of the box, or should you be more careful when using C# libraries that might have mutable states and things like that?
So no, yeah, if you use libraries that use OO patterns with stateful objects,
Yep.
then you get, of course, stateful objects in F#. So, and you have mutability in F# as well. You try not to use it, but when it's there, you can use it. So, but yeah, if it's a library that's really in the OO sense, you have to be a little bit careful, but you can use it. It's no problem.
Cool.
But sometimes you fool yourself, or you confuse yourself, because why is this happening? Oh, it's because there is some mutable state in there. But yeah, F# knows about mutability now, no problem.
Perfect. Yeah. So yeah, another question that we saw go by on the chat, but I think you almost answered that when I asked about NuGet and other libraries, was about mixing F# with C#. Is that easy? Is that hard? But I guess you covered most of that.
Yeah, our solution is a mix of about 30 C# projects and 5 F# projects. It's just you have an assembly is either C# or F#. You can't mix it in a single project. But you can, it's just .NET. So it's for the assembly, I just have a dependency onto another .NET assembly, so you can import it. It's the same, I think, with VB.NET. You can just import the VB.NET assembly in C# or F#. But of course, there are also some libraries that help with interop between C# and F# out there. And yeah, we do that. It works. It's not perfect sometimes because you have different designs, but it works really, really well.
Also things like debugging, etc. If you
no problem. You debug through F#, C# code, ping pong. It's absolutely no problem. Cool. That's really, really nice. Yeah. That's one thing I think makes it easier to start with F# because you can just add it to your existing code base as we did. You don't have to start from the green field to start with F#.
I have one more question, or actually it was more like a statement, and it would be interesting if you would say that we can agree on that, and that is Ian Russell, I hope I pronounce it correctly, might mean a few more lines of code, but that safety means that the number of tests required is reduced significantly. So in other words, with F#, do you also think test code becomes, let's say, reduced?
Yes, no. So I would say you don't have to have tests for things like nullability checks.
Something like that. Yeah.
The compiler gives you a lot of confidence, but we still write a lot of tests to test if it's the correct behavior. So you have no test for these little compatibility things, but for the behavior, you should still have tests. So
I actually remember I saw one talk which was about behavior-driven development. So that's like what was it? No property-based testing. That also
you can do that in C# and
right?
F#. So you can do this in both languages, but the most famous library is written in F#, fscheck.
Yeah.
So, but you can use that from C#. So there are a lot of F# libraries that you can use from C# as well. So yeah, I would say a little less tests, yes, but you still need tests.
Cool. Yeah, I think a lot of questions are really about C# to F# comparison. So I guess we can keep going on that topic for a while.
Yeah, I watched the talk from Chris and I kept track of all the 10 cool features and I just ticked them off that, okay, F# has 9 of them since like forever, but it would be an unfair fight. I would say just use the tool that works better. So we have some code that we would never rewrite in F# because it's really close to a device, so it's easier to write it in C#. But I think especially for business logic and modeling a business domain, F# has really its strengths.
So there's one thing we can agree on, it's both are sharp, right?
Yes.
Yeah, actually, you mentioned you ticked off 9 out of 10 top items from Chris's previous talk. So what would be the 10th, or are there any things from C# that you might be missing in F#?
Yeah, it's the default interface implementations, but that goes against as I understand it, the F# way to have that. But actually, that's not a feature I'm missing in F#. Because we don't have these hierarchies, inheritance hierarchies as much as we have them in C#, mainly because we have these discriminated unions for most of these cases. I don't know, things I miss. Yeah, the tooling is not as good. So there are some open issues in the JetBrains issue tracker about better tooling, support for F#. But the tooling is getting better in C#, it's getting better in F#. I think F# doesn't need as much tooling as OO language needs. So you have less concepts, there is more reuse of the same concepts. Like with this async, with this computation expression, it's always the same concept used in different contexts. Is it for asynchronousy or for optional values? But the concept is always the same. So I think in C# for every new feature there is a no concept, like this null coalescing operators, and so I would say it's the simpler language. So I had one slide in the presentation that I hid showed number of keywords in both languages. So I tried to count them in C#. I ended by 110, and I'm sure that that's not the whole number. And it was, I think, 97 in F#. So it's just as a random metric.
Did you also count the hidden keywords? Like there are a couple which are not really promoted.
I don't know. It's just official Microsoft documentation. I just counted the keywords there. So, but it's like Chris said, C# gets more complex and more complex and more complex with every version, and if that's something that doesn't happen as much to F#, I think.
All right. Let's maybe switch from pure language to maybe ecosystem. It's all .NET, of course, but I guess F# also has a little bit of its own ecosystem around certain libraries and so on. So what do you use in TimeRocket for UI, database access, and all of those things?
So F# we just use it for backend. You can build web clients with F#, with the safe stack, for example. But I don't know that, so I can't say anything about this. I just know it's possible. We just use it on the back end. And yeah, there are some typical F# libraries, but actually don't use that many. So I once tried to list them. It was about 7 or 8 real F# libraries that we use, mainly for testing, like this fscheck or just a unit test extension library. But it's mostly C# libraries that we use. So we run on ASP.NET, so we use all the NuGet package from there. We use Poly. It's just the most things are just the same in C# and F#.
Yeah.
So that's nice. When you start to learn F#, you actually know the ecosystem. You just can't just use what you always have used, and maybe you find a library that's just a little bit F# friendlier, but just stay with what is working. So we also use Dapper, the same Dapper we use from C#. So that's you don't have to learn a whole ecosystem when you go from C# to F#.
Yeah, that's pretty nice because I know I've been doing a lot of Kotlin in the past 2 years next to doing C#. But there it's learning a new language, but also learning a new ecosystem, because then you go from .NET to JVM and you need Gradle and you need all of the supporting libraries there. So as I hear, switching to F# or starting to work with F# is much easier in terms of jumping over.
Yeah, I would say that learning the ecosystem is much harder than learning a language.
That's true. Do you have any experience with other functional programming languages?
Not really. I learned ML. It's meta language, not machine learning, at university, but no. So I've seen some Haskell examples, but I can't write Haskell. No way. So now F# is the only, I would say, it's the only functional-like language. So I'm not sure that F# is not a truly functional language. It's a hybrid language, like C#. So it's just they call it functional first. So it's easier to do it in a functional way than in an OO way.
Also, what's interesting, have you, one of you have heard about the 7 programming languages in 7 weeks book? I do remember I read like to the second language and it started with Erlang, and it's pretty interesting actually because they point out the different strengths of each language. Which also leads me to the fact that was interesting. I met Matt Torgensen once, and those language designers, they have the regular meetings and they are pretty friendly to each other. So yeah, it's just a fun thing that they have their meetings together and
yeah, at the end it's just a tool. So use the correct tool for the right problem. Yeah. So there should be no how it's called. We should just be friends, and use whatever is best for our job to do. So I'm still writing a lot of C# code, so no problem there.
All right, let's have a look at the chats. Lots of opinions still going on there. Not a lot of questions coming in. Maybe one of the latest questions that just came in was about units of measure, whether that has been useful to have access to in F#.
It's just an additional tool that you have in F# to use measures. You can say it's something is kilometer, and you can say something is Newton, and then you have the type system that makes it easy for you to convert these measures into one another. But we actually use one, and it's a currency. But yeah, it's there, but we don't use it really.
But do you actually see a lot of people using it in different projects? And
no, but I don't see so many F# projects either. So in my past, it was all C#. So I don't know. Yeah, probably should ask that an F# consultant.
Yeah. That's maybe a good question. I think Chris also mentioned that that there were fewer F# projects in Sweden. I guess you could also turn that around and make it a business question. Like if you jump to F# and you start using F#, is it hard to find and attract F# developers, or do you hire C# developers and reskill them to using F# as well?
I would say it's quite easy to get a C# developer to learn F#. That's maybe a month to get going. Not to be perfect, but to get going, that's enough, because the ecosystem is the same. I would say if you have a F# job opening, you really get the people that are interested in doing it. So it's like a filter. But it's the same here in Switzerland. Not many companies use F#. But let's be honest, what is in 3 years? What is the programming language in 3 years? Even if it's F#, you have to learn the delta from now to then. So it's all about learning. So we should have a company that helps the developers to learn new stuff. If it's from C# to F# or the latest Azure services or whatever. So things change quickly in our profession. So we should have an environment that allows us to learn quickly, and then say the programming language is really not the problem.
I have one more question. Well, what build system are you using? Because that's interesting, right? Fake kind of started bringing.
We are really boring. It's just MS Build.
Just MS Build. Okay, that's choice 2. Back to XML.
Yeah, there's not much in there. So we just compile, and as a .NET test to run the tests. It's a really simple system from that point. So we don't have a lot of tasks to do. Of course, you have a little bit more complexity in the pipeline of the CI system, but actually, I always think that's a lot of over complexity with these build tools. So I just have to build, I have to run the tests, and it's fine. We don't have additional tasks in here. Yeah?
I didn't want to mislead the discussion. I was actually expecting you might say fake. Yeah. Because I think at that moment also they did a pretty good job, because it was probably the first more modern automation system in .NET space. And I think a lot of people also got interested into F# because of that. And I think there was something really great.
Yes, the nice thing about F# is you can use it as a scripting language. And it's really easy to go, just the same. But we never used fake. So we even in the C# times, we used all this C# build tools, and at the end we came back to MS Build, because if there is a new version of .NET, MS Build supports it, so you don't have to wait for the library. And which simply don't do much fancy stuff. So I think it's a little bit different for library builders. A library where you have multiple versions, you have to build it for all the target systems and all this stuff. That's a little bit more complicated, but with the .NET Core stuff that came with the multiple targets and so, it's, I think even there, I don't see the big benefit of introducing a new technology when you can just add a build task. So yeah, so we really like it simple. So if we don't really need technology, we try to keep it away, so not to overwhelm our 4 brains in our team.
I think that's a good approach of doing it. One more question came in actually about type providers. I think you mentioned that you're using Dapper to do database access, but I also know that there's, correct me if I'm wrong, this concept of having type providers where you kind of can extend the code completion and things like that with, for example, a model coming from JSON or XML. Have you been using that in the backend, and has that actually been useful to start using?
In our production code, we don't use type providers. One thing is that with the switch to .NET Core, type providers weren't really supported, as far as I know. I might be wrong here. And we already use Dapper in our C# code. So Dapper is easy to use, it's really fast, so we just kept Dapper. So some stability there. And one thing with type providers is, so you always have to compile them against the database. And the way we handle database changes and migrations just doesn't go really well with type providers. But I use type providers for things like CSV files, or getting data from an API. Say, okay, this is a sample set of data. The type provider creates all the types and all the properties on the records for you, and you have a fully IntelliSense navigatable data construct to use. So that's really, really nice. So for playing around with some data, writing some code for it, that's really great. Yeah, I think in C# a lot of people start now writing source generators to do the same. So
yeah, we've seen many people starting to do that for JSON, for CSV, I even saw a source generator that was using Excel files to generate some types and so on. So that's indeed the way to go. We are still waiting for our next speaker, so we can handle more questions if there's more questions.
Yeah, I'm very sorry, but it's F#, so the session was shorter than the C# session.